Finally, now gotten out my full install video for upgrading your V2 replica with T238's new spiral gear set and motor. I'll go through all the steps you need to successfully rebuild or upgrade the primary mechanical components of your AEG gearbox. A few unique and interesting things I noticed are the delayed tappet pin position for timing and the half-height second tooth on the sector gear. They also sent me a bunch of other goodies, which they call accessories on their webpage. This includes spare 18 gauge wiring, a shim set for gear shimming, and spare motor wire connectors, which you can never really have too many of. T238 just came out with gear sets, including a normal gear set and a spiral gear set, which is what I'll be installing today. T238's gear set offerings come in 13:1, 16:1, and 18:1 ratios. My first impression with these gears are they look pretty nice and remind me a lot like classic SHS gear sets in terms of look, feel, and general quality. The spiral gear set comes with the new spiral pinion gear and set screw. As a bit of a caution, the spiral gear requires a D-type shaft on your motor opposed to a round one, so you have to pay attention to that when you pick out a compatible motor. The D-type shaft is pretty common on Chinese make or model of motors. These T238 gears also have the cam for tappet pickup set back a little bit for an automatic delay. This will shift the BB feeding timing window compared to a normal sector gear. In this case, the cam is moved further forward, meaning it takes more rotation of your sector gear and more piston pickup to start opening up your nozzle, and then it will actually release later on the overall cycle too. T238 claims that this position will help higher speed full auto rate of fire, but most often if there's feeding issues in full auto, a simple selector delayed shift can help. Spiral gear sets should theoretically give you quieter performance, but only if you can shim them right, which is a little bit bigger of a challenge. You also need a shim set to complete the install, so if you don't have one, why not add to cart T238's shim set pack, as it comes with 0.5mm, 0.3mm, 0.2mm, and 0.1mm thick shims. Anytime you're doing your gear set is a good time to consider if you want to upgrade your motor. I chose to pair this 13:1 high-speed gear set with a high-torque motor to avoid excessive speed and wasting of energy. This motor by T238 also has the D-type shaft, which is perfect for this upgrade. This setup should give about 30 rounds per second if it's well shimmed, lubed, and tuned. I chose T238's 29,000 RPM 20 TPA neodymium brushed motor, which will actually perform closer to a 25,000 RPM once it's loaded. I've used the short version of this motor before from my ICS L86A2 LSW, and I put tens of thousands of rounds through that thing, so I know this motor is going to do just fine for this build. Before you go on to the next step of removing the motor pinion gear, make sure you remove the set screw, otherwise you'll start to strip things and damage your motor head. You also need a gear puller or pinion gear tool to pop off the pinion and press on the new one, which is the first real step to completing this gearbox upgrade. With the particular tool that I have, you first have to lock the head of your motor into the groove on the one side, leaving a gap on the bottom end of the motor. Then you screw down from the top end, which allows the round pin to press out your motor and motor axle, while the groove holds the pinion gear by its head. The issue here is the tool has a round pushing pin that's too large of a diameter to push through the D-shaped hole. So I had to improvise, and I ended up using a finer tipped tapered center punch tool to do the trick. Then you have to work in reverse and press on the new spiral pinion gear. First set the caps on the motor ends, on the bottom, and then at the top. Set your new spiral pinion gear in place. There's really only one way this can go, because there's the D shape, or one flat surface. And then screw down and press the gear into place from the top end. Don't forget to install the set screw, but before I do, I like to apply a small amount of blue thread locker. I'm going to be installing this setup into my new ICS hair arms that's bone stock. I hope you can tell from this video that the internals can use a performance boost. The next step is to fully disassemble your gearbox, and I'm going to fast forward these steps, assuming that you've watched one of my other full rifle teardown videos where I go in depth on that process. It's pretty much the same for most V2 AEG platforms. Once you've teared down your rifle to near nothing, make sure you give it a good clean and remove all the old dirt, grime, and grease. This rifle is actually pretty clean since it's bone stock and it's only been gamed once. Before I start shimming, I always like to set my bushings in with the epoxy. And if you have bearings, this might be a prime time to swap from bearings to bushings. If you're looking for bushings, I always recommend FLT bushings. Anytime with adhesive or glue, the key thing is surface prep. And here, you just need to wipe down and clean out your bushing itself, and the bushing hole in your gearbox with isopropyl or rubbing alcohol. To epoxy them down, I use steel 2-part JB Weld epoxy, black and gray mixed. This will ensure your bushings stay in place for uniform shimming, and it helps keep noise down in case the bushings end up getting loose and starting to spin themselves. I like to apply enough to cover the edges of the bushing hole, and then I set the bushing firmly in place. A bushing press tool can help, or a small screwdriver and hammer can help you set the bushing down, but just don't go too crazy on pounding. Then at the end, before things cure, I use a Q-tip and shop towel to clean up the excessive adhesive. Now set this aside and let it cure overnight. Now we go into the not so fun and very tedious part, gear shimming. I promised myself a long time ago that I'd never make a detailed shimming video. I'm sort of holding true to that promise. Here I'll show you brief steps, an overview of how I work through a shim job, but by no means does this show you every trick in the book. You always have to reshim, or at least check your shim job when you install a new gear set. To help out with this, T238 also sent me over one of their new shim pack sets, which includes 0.5mm, 0.3mm, 0.2mm, and 0.1mm shims. Like everything I do in life, trial and error are my favorite methods to shim a gearbox and airsoft rifle. While this method does take time, it's super simple, works every time, and if you apply a bit of strategy or logic behind it, trial and error can become pretty efficient. I've already inserted a 0.5mm shim on the bottom face of my bevel gear to bring it up to meet the pinion gear, and this is just to get us to start. Anytime you get new gears or a new motor, you have to reset your motor height and check your motor and bevel meshing and shimming. To do this, I start with the half shell method to get the motor pinion gear pretty close to where I need it to be to mesh with the bevel gear, and then I tend to fine tune it later if needed. The half shell method is useful because it allows you to see the pinion and bevel gear clearly so that you can check the contact and overlap. To start with the half shell method, just install half the gearbox shell, your grip, your motor, your bevel gear, and the motor end plate so that you can adjust the motor height until you have an ideal overlap contact and angle. You may need a flashlight, and you'll have to look at this from a few angles to observe how gears are sitting throughout the process. First, we should adjust the motor height to set the bottom edge of the bevel gear as close to flush with the pinion gear edge, and this will ensure good overlap of the gears. Now that we set the motor pinion to bevel gear, you can take the motor out and finish shimming the bevel gear to get rid of the slop on the opposite face. As you push your motor in or out to adjust the motor height, you shouldn't see your bevel gear getting binded or twisted about, and that could signify it might be shimmed too high. And if it's too loose, then it could stand to add additional shims a bit later. This type of fine tuning is best performed with the gearbox fully closed so that the bevel gear is being held the most stable and not wobbling. In most gearboxes, you can still see the bevel to pinion through one of the cutouts or open holes in the side of the shell, even while it's closed. I also recommend to always insert your motor and your motor grip the same orientation. This is usually obtained automatically because your wiring will be different lengths and the motor may really only get in one way to be able to reach the wires, despite which you think everything's not perfectly symmetrical thanks to manufacturing tolerances. Once the bevel and pinion gear are set, we can move on and shim the rest of the gears one by one. Next, we move on to shim the bevel and spur gear. At this point, you can leave the motor behind and just work on shimming the remaining gears in side-by-side sets, aiming to obtain optimal gear overlap and minimize slop and wobble. As you watch me crudely step through the various parts of this process, I'll share a few tips that I use as I go along my way. Gears shimmed slightly loose is better than having them too tight. Have some patience during this process. All gearboxes will shim differently. There's no correct number of shims. It can reach a point of excess. I always try to have at least a single 0.1mm shim on each face of each gear. Surprisingly, sometimes this is pretty tight. If you can find a shim set that has 0.08mm or 0.15mm shims, then pick it up. That slight 0.05mm offset can allow you to tighten your shim job up. Target as much gear overlap as practical, but not too much, because then there won't be any tolerance for things. I'm usually happy if I can get around 80% gear teeth overlap. In very challenging gearboxes with unique gear conflicts, I've settled for less as well. When you shim a gearbox, you'll need to unscrew and rescrew your gearbox together many times. Yes, actually screw your gearbox halves together with enough screws to hold solid pressure between the two halves. It's tedious, but just don't be that finger pressure guy. Carefully balance tightness in play. It's a fine line, and sometimes that extra 0.1mm shim was too much. With this gear and gearbox combination, after test firing, I noticed that the tappet pickup post where the cam on the sector gear was cutting into the upper gearbox of this ICS split shell system. Not sure if this is just going to happen on ICS gearboxes, but be cautious to check your clearance to the nub and file it down if necessary. In my case, the conflict was due to the post being about 0.25mm longer than the stock or standard ICS gear set, and I couldn't raise the gear higher by shimming it enough without causing other issues on the other ends or in other gears. The start of gear meshing is really governed by a good motor, pinion gear, and bevel gear setting. Then everything else ripples through there, not usually the other way around. To solve this problem, I just took a file to the nub on the T238 sector gear, and I took it down enough to clear. I also filed down the gearbox shell where the contact was made, mostly to smooth out the gouge and deburr. When you're all done, don't forget to rinse or blow out all the metal shavings from the gearbox, and clean the gears thoroughly to make sure your parts are spotless before running the gun and firing. The last thing that you want is to have metal shaving remnants left in your gearbox, otherwise you'll end up being as popular as the 3rd gen Toyota engine. Once you're happy with the shim job and you've dry test fired, you can go ahead with greasing the gears up. You want to hit all the steel to steel contact surfaces with your favorite Airsoft gear grease. The grease that I'm using is a modified gear grease. The goal here is to get a healthy coat of grease everywhere, but not too much or so much that it's going to fling off and cover your ETU or MOSFET board sensors. You also don't want to gum up between the teeth too much with grease because it'll also affect how sensors read your cycle. You want to try to spread grease evenly throughout the moving parts, including between each gear teeth and around the axle and bushing zones. And for this, the best way I've found is to use a brush. Spiral gear sets are typically quieter, can take higher stress. However, in most Airsoft builds it's not really a problem. Due to all the teeth angles, they can be more difficult to shim, but if you can get them shimmed correctly, the quieter sound and durability can be a big plus. Finally, you can now go on to full assembly, power it up, and really test fire. If you test fire under no load, the gears may sound a little tingy still, which is normal. The best way to hear how it sounds is to test fire under load and as a full system or assembly, because that's the true condition and position of how your motor and gears will be working. If you've enjoyed this video, don't forget to check out T238.net, and you can actually pick up all the parts I've used today, including the motor, the gear set, and the shims. At the end of the day, I'm pretty happy with the final job. The output's producing around 28 to 29 rounds per second in full auto, using a fully charged 11.1 volt LiPo battery.